Is we have seen like what is microprocessor and then how to design a system based on microprocessor is what we have seen. Now what we do is we will try to take up the topic. Okay, so the next topic, that is microcontroller, introduction to microcontroller. So what is the need for microcontroller when we have microprocessor? You may be getting a question. So now the difference between microprocessor and microcontroller is what we try to see in the beginning. And then what we do is, then we'll try to see the architecture of 8051, a standard microcontroller. As I told you, this 8051 is manufactured by Intel. Then there are so many manufacturers, but I think there are two microcontroller chips are given in your syllabus. One is Intel based 8051 and another one is PIC microcontroller, I think. So these two controllers are given as two chapters. So we'll try to see in detail how to use, and then other manufacturers also there like Atmel microcontroller. These days everybody is using Arduino board. So Arduino board, the on-chip microcontroller is Atmel based microcontroller. So Atmega 16 or Atmega 328, which is much complex microcontroller structure than 8051. So the basic idea is why we are now in 80 microprocessor also, when we are trying to see, we have seen only 8086. Why? Because Intel follows the upward compatibility. Upward compatibility means the instructions which you are writing for 8086 also can be executed by 80186, 286, 386, 486, 586 Pentium, i3, i5 processors also. So Intel makes that much care. So that's why we are studying the standard structure of this microprocessor family or microcontroller family. So now what we do is we'll try to take up the microcontroller, what exactly the microcontroller is. Difference between microprocessor and microcontroller is what we try to see, and then what we do is we will try to take up, if you want to know the functions performed by the microcontroller or microprocessor, architecture is, you have to know the architecture to see what facilities are available or what features are available within the processor or controller. Then if you want to get, if you want to get any applications out of this processor or controller, then we need to know the instruction set, because by using those instruction set only you can command or control, or you can instruct. That instruct is the correct word. So instruct microcontroller is okay. So then in this class what we try to do, we will try to see what is the difference between processor and controller, and then we'll try to see the architecture of a standard microcontroller, that is 8051, and we'll try to see the resistors available, and then the hardware features of 8051 is what we'll try to see. And then we'll try to see, if time permits, then we'll try to see the instructions, means addressing mode. If at all, if you want to write any programming, then you have to know the addressing mode. So what all we did for microprocessor, that you should apply or extend. So microcontroller should become easy for you from now onwards, because you have something in mind. Okay, so now with this, let us start today's class. Okay, so now let me share my desktop. Okay, so that let me share my monitor so that you can be viewing, right? So now let us try to see So now let us introduce microcontroller, what exactly it is. Now, the moment we say it is a programmable system, the best examples are processor-based systems or microcontroller-based systems. So now any microprocessor system means what we said up to now. So this is what your microprocessor, and or which we can call it as CPU, central processing unit, and then here you have, being a programmer, you will be writing your program in the memory. So that memory is of RAM and ROM type. So that is of RAM and then ROM. So how to interface this to microprocessor 8086 is also we have seen. Right, and then if you want any other systems, and then to give the instructions to the processor, we need input devices like keyboard, and to see the outputs like displays and all. So input output devices are we are interfacing to the microprocessors, and to design to make a system, what we are trying to do is we are interfacing RAM and ROM, and then we are using some decoders here, and then like now if you have peripheral devices, okay, peripheral devices, other peripheral devices like input output devices like pen drive, CD drive, printer, okay, all these things, if you want to interface, then you are trying to interface these things with you are trying to interface this with 8255. That means you need ports. So port pins is what you try to need if you want to interface any peripherals. So the peripherals can be like, you can take like, this is a pen drive kind of thing, okay, or otherwise a CD drive, okay, CD drive, and then a printer. You can take it as printer, and then you can take it as a mouse, input devices, output devices, okay, then mic, okay, if you want to connect mic. So these are the peripherals you want to interface so to microprocessor. So then what we need to do is we need to interface that to 8255, and then 8255, okay, in turn, the processor, communicates with the devices through 8255. That is which we call it as a port. So to design a system, okay, if you want to make a processor system, microprocessor based system or programmable system, so we want memory, we want other peripheral devices, and then the peripheral devices can be connected through 8255. And now for any system, any computer kind of thing, we need time, that we call it as a real-time clock. Okay, real-time clock. So that real-time clock or some kind of thing you can generate by using 8254. Okay, your timer IC is there, 8253. So 8253, your timer IC 8253. So timers need to be interfaced to the microprocessor. And then after that, what you need to do is, and if you have more number of devices, that more number of devices can be more number of devices can be connected to the microprocessor. Then each device need to be serviced. So then what we need to do is we need to connect 8259 programmable interrupt controller also we need to interface. So here we are using a word interfacing. We are not calling it as connection. I already told you why we are telling, why we are using the word interfacing here, why we are not using connection. So the reason is, so here the reason is connection means simple one pin to another pin connection, but we are using n number of devices. So this device can be of TTL, this side device can be of HMOS, the other devices can be of CMOS, so other ICs and all. So all these devices we are connecting to make a system, right? So then the logic levels of one system and another system may be different. So connecting in a compatible manner is called interfacing, right? So in microprocessor, interfacing is the word which we use, not the microprocessor and connection. Right? So this is already we discussed. So now let us try to take, if you are connecting your pen drive or CD drive kind of thing, so then if you want to do a huge data transfer, then that huge data transfer you can try to do using 8237, that is 8257. Your 8257 is what? DMA controller. So we want DMA controller. Okay, so the DMA controller, that means your pen drives and all, you can connect to the microprocessor through DMA controller, so that very fast, okay, very fast data transfer can happen, right? So to make a system, what we are trying to do is we are trying to connect RAM, we are connecting ROM, where you can BIOS and all can be stored, right? Operating system can be stored, and we are connecting 8255, we are connecting timer 8253, and we are connecting 8259. And if at all, if you connect your, means, if you are connecting your keyboard, so then if you are connecting your keyboard and display, so you have one more IC you need to connect, that is 8279, which is a display controller. So 8279 also you need to control, you have to connect, right? So you need to interface. So 8279 is also one more interface, and so like so on. You can extend the capability of the process of the system by keep on adding the other ICs. Okay, so now this is what the microprocessor system, which we up to now, which we have seen, right? So now, what is the disadvantage of these kinds of systems? It is a microprocessor. How we define microprocessor is a general purpose device which can perform arithmetic, logical, and control operations. So here, more logical and more arithmetic operations it performs, and less control operations. But sometimes we need few systems which has some dedicated applications. See, the processor will do general applications, but sometimes we may need some devices which are of dedicated. Right, so that means now dedicated applications. So here we have dedicated application, means more control applications we may need. So control applications. So more control applications we may need, right? And that is one more thing. So example, you can take toy car. Okay, toy car you can take, the children, they will play at home, right, the toy car. So there it is what, it is movement of toy or the car from one place to another place, either forward direction or backward direction or left or right, that's it. There is no arithmetic or no logical applications need to be performed over there. It is just controlling the speed of the wheels, and then the direction, okay, the direction control. So here more control is what we need. So dedicated, there are few applications, then these kinds of systems are not needed. Even though we have seen like 8086 how it can be interfaced to a stepper motor, and then stepper motor rotation, how processor is controlling the direction of movement of the stepper motor is also we have seen. Right, so processor can perform more arithmetic, logical, and control applications, but generally the processors are used for less control applications and more logical applications. But there are few applications which demands a dedicated applications, like only more control. We can say more control applications and then less logical or arithmetic operations. The another example, so example I can take it as one is toy car and another one is elevator or lift. So now if you try to take lift elevator, so here what you will do, the moment you press the button 1, it will go to first floor, or if you press the buttons 2, it goes to second floor. So it is only the control, the direction of controlling, direction of the motion of the lift, it has to be controlled. So there are few applications which only needs more control applications, but lesser logical applications. So then those kinds of applications, when it is, then here the disadvantage of this kinds of system is, if at all the processor has to perform a particular task, then what it will do is it will fetch the instruction from the RAM, and then the data has to be transferred to the microprocessor, and there it executes the program, and then it takes a decision. So the data transfer is from outside world to the processor and processor to the outside world. So then the data transfer can become slow. Remember, here the data is transferred from one chip to the another chip, right? So the moment you are giving input and output, okay, so then here also peripherals 8255, when you are trying to interface the data transfer is outside and inside. So the first point what we need to do is to make a system. So now a programmable system like our cell phone. So if you want to make a programmable system, so what we need to do is we need to interface, okay, we need to interface so many devices or so many ICs, we can say, so many devices you need to interface, right? So then the data transfer, right, the data transfer is from outside world to outside to microprocessor. So then data transfer, getting slowed down. That means data transfer speed is slow. Then that is one reason. The another reason is, it occupies more space. So to overcome these difficulties, what it is done is, if the memory, what are all we discussed, if the memory is available on chip, the data transfer is within the chip. If you have ports on chip, so then you can easily interface the other devices. No other IC is needed. And if you have timers or control, the timers and counters on chip, then it will be better thing, so that you can you can use the facility, right? So microcontroller is the device which has these things on chip, right? Now there is one more IC is also added up here, which is called 8251. This 8251 is USART. That means the processor at a time it can send 16 bit of data, and if I want to transfer this 16 bit of data from one place to another place, let us take Warangal to Hyderabad. So then I need to establish 16 lines, but that will be very costly. So then what I do is I convert the parallel data into serial data, and then the serial data I transmit over a line. A single line is enough for that. So I need 8251, which is USART, right? Universal synchronous asynchronous receiver transmitter. So if these things are available within the chip, your timer chip, your 8255, your 8251, your DMA controller, anyhow, that is not needed here, because here the only control applications we need to perform, not the logical or transfer applications. So then there is no DMA. But whereas all other things like we need the timers, and we need interrupts, devices need to be serviced. So all these devices we can, if we can find on a single silicon chip, then that will be getting advantage. So that is nothing but microcontroller. So microcontroller is what? It is, system on a chip. Okay, this is, if you have an IC, what are all we talked about, that you can find on IC. So that is, system on chip. Right, you have a system on the chip itself is what we call, but okay, generally, but everything we are trying to make within a system. Then in more, what is the advantage of this if you get is, like fabrication of one IC costing or fabrication of 1,000 ICs, both are same cost. So then, if these devices are made upon one IC, the cost also getting reduced. So cost is also, right, cost is also getting reduced. The cost is also getting reduced. The cost is also getting reduced. So everything we are getting on chip, and that is nothing but your microcontroller is, right? So which has on-chip RAM, which has on-chip ROM, which has on-chip timer, which has on-chip ports, which has on-chip, interrupt managing facility, which has on-chip UART. Okay, so all these things, if they are there on the same system, then we can call it as microcontrollers. Is it all right? Okay, so this is what your microcontroller, where we have all the things available on the same ICs. Okay, so that is what microcontroller. Now let us try to see this microcontroller in detail. Is it all right? Okay, so now let us try to see how Intel brought all these things and then made an IC which is 805. Okay, so now with this background, let us move to the details of 805. So is that all right? Okay, so now let us try to see the microcontroller and its architecture, and what we did for micro processor, the same thing we need to do, like we have to see the architecture, we have to see the registers available and memory mapping or memory organization, and then addressing mode, instruction set, because architecturally yeah, one more difference, one more point here I want to mention is your microprocessor is of one Neumann architecture. So the microprocessor is one Neumann architecture. But whereas your microcontrollers are Harvard architecture. Harvard architecture. So when the architectural differences are there, the instruction set which is written for 8086, there is no need to execute it on 8051. Okay, so is it all right? So that is what. So controller has a specific architecture, so it has own instruction set, so we need to see instruction set too, right? So that means one Neumann architecture I already told you, right? I already discussed, like if you have a microprocessor, if you have a memory, you have address bus, you have data bus, right? So if you take a memory, so then you have an address bus and you have a data bus, right? But so here the memory, you are dividing that into like different segments, like code segment, data segment, okay, different segments and all you are trying to do, right? If you have microcontroller, you have all the chips all the peripherals are on chip. And now if you try to take your microcontroller, and then the microcontroller, if you have, your codes are stored in separately, in RAM and then ROM. So ROM has separate address bus and RAM has separate data bus. And RAM has separate address bus and RAM has separate data bus. So we have seen already what exactly the address bus and data bus. So you have different, address bus and data bus for specific memory. This is Harvard architecture. So this is, Harvard Harvard architecture. And here you have only one address bus and data bus for memory, and then this is von Neumann architecture. Von Neumann architecture. Is it all right? Okay, right. So this is von Neumann architecture is and Harvard architecture. So then when architectural difference, then when that is there, so then definitely the instruction set of 8086 and the instruction set of 8051 are they are different. So now we'll try to see the addressing modes and all. So now the contents for this lecture are, so we'll try to see the introduction and we'll try to see the block diagram, the pin description, the registers, then the memory available with 8051, and in the next class I will be discussing about the port programming, like what are the ports available with 8051 and the timers and then the interrupts, right, and then interfacing of LCD, interfacing of A to D converter to 8051, right, and so on, right. So we'll be dealing with, so another 2 to 3 classes we'll be discussing on 8051 only. So the 8051, as you see right now, if you see, so this is an IC, right. But physically, if you want to see, like I want to see a timer, you cannot see timer there, but it is an IC in which you have the circuits on. You used lithography technology and then printed on the silicon chip. Okay, so this is an IC only, 8051, a microcontroller which has everything which we discussed up to now. So I already discussed, why do we need to learn microprocessor and microcontroller. So the processor is the core of computer system, but nowadays many communication and digital entertainment portable devices are controlled by them. So a designer should know the types of components are needed, cost, and then different aspects. Okay, different aspects, different aspects of microprocessor controller, hardware point of view, software point of view. Right, and then the necessary tools for microprocessor controller are CPU, I/O, timer, interrupt, serial ports, and parallel ports. So then microprocessor system, as we said, we are interfacing RAM, we are interfacing ROM, I/O ports, timer, and special ports. Right, but whereas in microcontroller, everything is inbuilt. That's what we discussed up to now. Your ALU, CPU, and your RAM, ROM, ports, RAM, timer, and serial to parallel or parallel to serial converters. Okay, so they are available on board, on chip. You can say on chip. So the differences between microprocessor and microcontroller: CPU is standalone, RAM, ROM, I/O timers are separate. But whereas in microcontroller, CPU, RAM, ROM, I/O ports are all on a single chip. That is the first difference. Designer can decide on the amount of ROM, RAM, and I/O ports which need to be connected to the processor. But here in microcontroller, they comes in while fabrication itself. So the amount of on-chip ROM, on-chip RAM, and ports available, they are fixed. Right, you cannot add up on, so you cannot extend because they are given how much that is. It is it is an expansive, and for application in which the cost, power, and space are critical. So microcontroller is occupies less space. Microcontroller based systems, than microprocessor based systems, and cost also less for microcontroller based systems, and it is a general purpose, but it is a dedicated applications. Microcontroller is for dedicated application. That's what we have seen now. And where we use this microcontroller is the microcontroller in embedded systems. The processor is embedded into that particular application. It's like your projector. Projector is an best embedded systems. A system within a system. So controller is the base. So the processor or controller is the CPU of that particular embedded systems. So what are the criteria we choose of selecting a controller? So one thing is the speed of, so first thing the speed, next is the amount of ROM, RAM, and the number of IO ports you need, number of IO devices which you can connect, and then the number of timers and the power consumption, right? Based on the power consumption, you can choose, and the upgradation point of view, these days one microcontroller if it is released, and after some days, some a good feature microcontroller is coming into the market. So then when you upgrade, then easily you should upgrade from one to the another environment. Now let us take, I'm using Windows. If suddenly Linux is given to me, right? Windows, we know Windows 7, Windows Pro, Windows 10. Now we are in Windows 10. So what the system to another system and they are upgrading, then the user should not face the problem, right? Similarly here, we have to easily to be upgraded. Then cost also we'll try to see. And then now once the, and one more thing, if you are there in Kakinada or if you are there in Vizag, then that particular controller is available or not is also important. Right, 8051 is available, or that fellow may be selling Atmel. Now if you are moving from from India to Europe, then there you may not find the controllers which are there in India. Right, so the availability also we'll try to see. So then that is also one factor, availability is also one more factor. And when you are trying to write programs, like now we said like on chip ROM is available. ROM means ROM or EEPROM. When you are trying to dump your program which you have written in your computer, then you should have the software development tools, like you should have Keel, and then that is an assembler, and then which converts your assembly language program or C language into low level, and that low level program has to be dumped onto your ROM. So then the development tools should be compiler or emulators or simulators should be available. So based on this, somebody may be making this simulator, they are paid. So availability of software development tools we'll try to see. Okay, so these are the factors we choose or we will consider while choosing a microcontroller. So now if you try to take any general purpose microcontroller, so now if you try to take any general purpose microcontroller, so then the general purpose microcontroller can be of this kind. The architecture is of this kind. Now if you try to see in detail, so here you have a CPU. So now if you try to take, this is what your CPU, the core, right? So then your microcontroller. And this CPU has to be, and then that clock can be generated by using an oscillator, right? And then the controller has the inbuilt in the internal data bus on chip itself, so internal data bus, and that data bus where we can interface on chip RAM and on chip ROM, and then port pins. Generally all microcontrollers, 8-bit microcontrollers has 4 ports, and this we in microprocessor we are trying to do this with the help of 8255, which has 3 ports only, port A, port B and port C. Each port has 8 lines, right? And then on-chip timer, and then counter. But whereas in microprocessor based system we used 8253 timer, right? So this is also on chip, and then serial port. So serial port means the parallel data has to be converted into serial data, or the serial data received has to be converted into parallel data, because the CPU is of a parallel device, right? The microcontroller is a parallel device. Means if it is 8-bit processor, it will use 8-bit at a time. If it is 16-bit processor, 16-bit at a time. Microcontroller, if it is 16-bit at a time, it can give. Is it all right? So now this is what the block diagram. So now by closing eyes, you should draw this diagram. Block diagram of microcontroller. If somebody is asked after listening this class, then you should say yes. To make a programmable system, I already told you what is programmable. You can change features, right? Okay, so cell phone is the best example of your programmable system. Then you have to close eyes, like these are CPU, and then you should have RAM, you should have ROM, chip ports, and then you have timer IC, and then you have serial ports and all. Okay, so this is what the block diagram of microcontroller is. So 8051, it is of 8-bit microcontroller. It is of 8-bit microcontroller. Okay, it is 8-bit controller. What do you mean by 8-bit? How you say 8086 is a how many bit processor? 16-bit. Say it is 16-bit based on its ALU. So ALU bit, the ALU is of 8-bit means what? It can perform arithmetic or logical operations on 8-bit at a time, right? 8051 is of 8-bit microcontroller, and it is widely popular in Intel based. And in 8051 family, you have 8051, 52, 31. Differences and all you choose. Okay. So now Intel microcontrollers family, if you try to see, now you see 8051, 8052, 8031. Here you have on-chip ROM of 4K on 8051, but in 8031 it's not there. 805 to 8K ROM it is there. And coming to the RAM, it is in bytes. 128 bytes on-chip RAM, 256 bytes on 8052, 128 8031. The number of timers available on 8051 are 2, 8052 are 3, and 8031 are 2. These are the family variants of 8051. The number of I/O pins are 32, 32, 32. Serial ports are 1, 1, 1. And interrupt sources here, interrupt sources are 6 on 8051, and then 8 on 8052, and 6 on 8031. So this is the family. Now, if you try to see 8051 features, now give a glance. What they are: 64 KB program memory address space, 64 kilobytes. 64 kilobytes data memory address space, 4K bytes of on-chip program memory, 128 bytes of on-chip data RAM, 32 bidirectional individually addressable I/O lines, input-output lines, two 16-bit timers counters, full duplex UART, and 6 sources or 5 vector interrupt structures with 2 priority levels. An on-chip clock oscillator. On-chip clock oscillator. These are the features of 8051. With 100-150 rupees, you get this. Processor is also 100-150. But to make a system, then you have to add all these things. Means 8255 costs 100-150. 8253 costs 1 more 100, and 59 costs around 150-200. So the cost, if you want to design a system, it may become 1000. But all these things available on a single IC with 100-150 rupees. That is the advantage of 8051 if you consider. Now, if you try to see the pin diagram of 8051, it is a 40-pin IC. So now you just give a glance on the 40 pins. Port 1, this P0, port 0, port 2, This is port 3. Each port has 8 lines. So how many lines? 32 IO lines are there. Right? This AD0 to AD7 are 8-bit address or data bus. Right. So address or data A15 to A to A15. So how many address lines are there with 8051? 16 address lines are there with. So now address lines 16, data lines 8, ports 32. Right. So the moment it is a microprocessor or microcontroller, I told you in my first class, right? I discussed in the first class, you have to know like what is there on the moment you say microprocessor or microcontroller, you have to, some points should come in mind: address bus, data bus, control bus, ALU, registers, right? And then program counter, stack pointer, then externally initiated signals. This I discussed in my first class very clearly. Yes, right? So now the same thing will extend it to 8051. Then it will not become any difficult. 40 pins are there, 32 gone, 16 gone. So then here we say the program, the one more difference between microprocessor and microcontroller is here you have programmable pins. Means each pin can perform different operation. Now here if you try to see, this pin can act in sometimes it can take it as address bus, it can act like port also. Two functions it performs. Like ports are address, and this is only port. This is receive data, transmit data, serial data transmission. You can try to do this. So these are the interrupts, and reading and writing you can do through these particular bits. You can connect your crystal XTL1, XTL2 here through this particular pin 18 and 19, VCC and ground. So here each pin will perform multiple tasks. That's why they are called programmable pins. 8051 pins are called programmable pins. Is it all right? Okay. So now the pin diagram, the pins which we didn't cover up to now is ALE 30th pin and EA 31, PSCN 29. We'll try to see what they are, and rest everything they are very simple only. Now if you try to see the architecture of 8051, the block diagram of 8051, now let us try to see. So the moment I told you the architecture, the moment we see the architecture of a processor or controller, right, the moment we say the processor or controller, then do is I told you few parameters, few things should come into your mind. There ALU. See, now you try to see address bus and data bus. So address bus and data bus A0 to A7. So that means port 0 will perform all the function. They are IO ports and then data lines and address lines. Right. So this is what. And here you have an arithmetic logical unit which is of 8-bit. And here you have some resistors. The resistor is resistor A and resistor B, and PSW, programmable status word, which we call it as flag resistor. Programmable status word, program counter, right? Program counter, data pointer. This is new in processor, and the rest everything is same. And on-chip ROM and on-chip RAM and special function resistors. You have special function resistors. You can separately write, no problem. So these special function resistors are mentioned here. And the RAM are mentioned here. So the block diagram of 8051 is very easy. The moment you have concepts in mind, then you can say like it has an ALU, arithmetic and logic unit. Wherever there is ALU, there should be a resistor called accumulator. Then resistor B here, in this case of 8051. And nearby you can find PSW, programmable status word or flag resistor, because once you execute an instruction, to know the status of that particular instruction, the status of after completion, execution of the instruction, then you have to know PSW, programmable status word, program counter, PC, to point out the next memory location from where the controller has to fetch instruction. And you have on-board ports, no, on-chip ports. Port 0, port 1, port 2, port 3. How many ports? 4 ports. And the moment we say a port, the moment we say an output port, it should have a latch. Already discussed in 8255. The requirements of ports. So that should have a latch and port pins. Now this is what the block diagram. Simple. Try to see. ALU, accumulator, programmable status word, program counter, ROM, RAM, ports, port 0, port 1, port 2, port 3. But if it is in output port, then it should have latch. If it is input port, then it should have buffer. And buffer is not mentioned. So you can write buffer/latch port. And then port 0 can work as an output port pin, address pins, and then it can carry the data. So 3 functions the port 0 pins performs. That's why they are called port pin programmable, not port pin programmable, programmable pins. 3 functions the port it performs. Then port 1, it is simple IO, and port 2 it performs 2 functions. Port 2 pins it performs 2 functions. One is IO port lines, and then higher byte of the address it can hold. And port 3, oh, so many. IO, interrupt, counter, serial data, read write and all. Port 3. So by closing your eyes, you should know what is there in the architecture of 8051 or any microcontroller. So these concepts I gave you in the last classes, right? So then the architecture, So the book you need to follow for this topic is 8051 Microcontroller by Kenneth J. Ayala. This architecture I have taken from that particular book. Very simple, you can draw, right? So the moment you know you are going for anything, drawing should be should become it is ALU. So then you can draw few internal data buses. ALU, nearby ALU you should have PSW, programmable status word, and then you have accumulator, then you have B register, right? And then here you have RAM, and here you have ROM, and here you have ports, port 0, port 1, port 2, port 3, right? This is RAM, and then RAM special function registers, right? So this is what simply you can write architecture you can draw, right? And now program counter. The moment you have RAM and ROM, you have program counter, data pointer. So this data pointer, the moment the program counter is of 16 bit, 64 KB, but RAM is off. Now if you try to see the features of the RAM, now you check it out, the features of the RAM. You have 8-bit CPU with registers, accumulator and B, 16-bit program counter and data pointer. So 2 power 16 means 64 kilobytes of memory it can access. So this program counter is used to point out the memory locations on chip, which is ROM and RAM. So the RAM, which is of 128 bytes, is pointed out using this program counter. And data pointer is used to point out, like if you want more memory need to be interfaced, you can add up one particular IC. 4K is on chip ROM available, yes, 0 to 4K. So the RAM available is of 128 bytes and ROM available is of 0 to 4K. Right, 0 to 4K. Right? So to point out if you need the memory more than 4K, then externally you can connect external ROM, and to point out that external RAM we need data pointer, DPTR. Repeat. Program counter is to point out the memory locations on chip. Data pointer will point out the memory locations if at all, if you need any external memory. And coming to the registers, you have 4 register banks, each containing 8 registers. Around 32 general purpose registers are there. How many general purpose registers are there with 8086? Accumulator, base register, count register, DX, 4. But here 32 general purpose registers are there. And 16 bytes which may be addressed at bit level. In this 16 bytes out of 128 bytes, 16 bytes are bit programmable level. Microprocessor is one more difference is microprocessor is byte programmable. Microcontroller is bit programmable. I can take the data 8 bits at a time in the processor, and processor can send 8 bytes, means 8 bits of data at a time. But microcontroller, you can make a particular bit on or off in the memory, which is called bit programmable, or the memory which is of 16 bytes out of 128 bytes is bit programmable, means individual in that memory you can make one particular bit 1 or 0. You can store one bit 1 or 0, which is bit programmable. But this facility is not there with microcontroller. This is also one more difference: byte programmable, bit programmable. and you have 32 input output pins arranged for ports, and you have two 16-bit timers T0 and T1 timers T0 and T1, and you have full duplex serial transmission SBUF, and the different registers are there, like timer control, okay, timer mode set, serial control, power control, IP and IE. These registers are there with microcontroller. Two external and three internal interrupt sources are available, and on-chip clock circuit, on-chip oscillator and clock circuit is available. So VCC pin, and then now here you used to try to see. Now we'll try to see the pin diagram of 8051. Here you have XTAL1 and XTAL2, 19 and 18 pin of microcontroller. Anyhow, VCCs and ground, they are power ones, right? So now you connect an oscillator, oscillator to this XTAL1 and XTAL2 external oscillator, and then you connect these through capacitors, one and then capacitor, two capacitors are connected to ground to bypass, is there any surge or some kind of thing. So this is how you can generate clock in 8051. So 8051 works with a clock of 5 megahertz. Right? And next one is RST pin, reset pin. We know what the moment you give a high on this reset pin, what happens? Your program counter will become 000, so afresh you can start. Yes or no? So it is a power on reset. The moment the power is off, then it will reset on its own. So this is what your power on reset circuit. 5 megahertz or 11.0592 megahertz. Right, push it. This is capacitor. So then EA is external access. So the pin number 31, in 8031 there is no on-chip ROM. Then you can use this EA pin and then you can connect external ROM. Okay, so that EA pin is external access. That is in case of 8031, 8051, anyhow. So by default you connect it to ground. It is connected to ground means it indicates the code is stored in external ROMs. This PSTN and ALE are used for external ROM, and this PSTN is programmable, program store enable. This is an output pin and is connected to OE pin of your ROM. Output enable. ALE as usual, address latch enable. And this ALE pin is, why you use this ALE pin? This is also there with 8086, right? So why do you use? To demultiplex your address bus and data bus, right? To demultiplex your address bus and data bus, we use this ALE. Here also we have 80 to 87, means same pin is used to carry the address and to carry the data. Right. So to demultiplex, we use, and this can be done by using latch 74LS 373. This is already we have seen. Port pins are 4. So now coming to the registers of 8051. These are the general purpose registers, they are available. Accumulator, B register, base register, R0, R1, R2, R8. So these are 8 registers. And data pointer, DPL and DPH, data pointer, program counter. So these are 16-bit. Okay. Program counter and data pointer. So these are 8-bit registers. Means it can store 8 bits at a time. Right? And now coming to the ROM, the memory mapping of 8051, as we said, This is this is Atmel family. So this is we are discussing 8051. So 4K now you can give very clearly you have 4K RAM, whether it is Atmel or what, don't bother about it. You have 4K ROM, you have 128 bytes RAM. So then 128 bytes RAM means what is the memory can be given, the memory addresses. What do you mean by memory mapping? Memory mapping means what? Giving addresses to the memory locations, right? You have on chip 4K RAM. So 4K RAM means here you have 4K means 3 digits if you use 0002 FFFF. Right, FFFF. So then now this F into 16 power 0 plus F into 16 power 1 plus F into 16 power 2. F is 15. So F, now if you try to take, then you will be getting 4K. Okay? Right. So then how this is not needed for 8051. This is what enough. Okay? And coming to the RAM locations, how much memory is there? 128 bytes of memory is there. So 128 bytes means if I use only one digit, hexadecimal digit, 0 to F, 16 bytes only I can use. But if I use 2 bytes, 0002, last is FFFF, 11111111. It is an hexadecimal. FF means 256, but 256 not there now, only 7F. So that means half of 128 bytes is half is what? 7F. After 7F 80 will come, right? So the memory addresses can be given, the RAM memory space allocation given is 0002 7F. Right? So this memory of 128 bytes is very important. The RAM location, the RAM you should know. This 0002 007, this is register bank 0. Register bank 0 means, see we said here the registers if you try to see R0 to R7, 8 registers are there. So this is bank 0. So this is bank 0 means 8 bytes of this RAM can be used as register. 8-bit registers, 8-bit registers. Similarly, you have bank 1, bank 2, bank 3. So each bank is of 8 bytes. So 4 8s are 32 bytes are for general purpose RAM. So this memory can be used as internal storage or you can use it as registers. So out of 7F, 32 means, see now 1F is the last address. 1F, F into 16 power 0 plus 1 into 16 power 1, F into 16 power 1. So here F is how much? 15. So 15 16s are plus here 16 power 0, right, 15 into 1, right, this plus this. So it is 16 power 0, 1F now. It's 15 plus 15 16s. So total this address. Now we try to see 00207 is 8 bytes, 0820F is another byte, and 10217 another byte, and 1821F is another byte. Okay, so total 32. Sorry, this is 17. This is 17. So 1 into 16. So 1 into 16 plus 15 into 1. That's what I am worrying about. So here 1 into 16 for 1. So 16 plus 15. 31. And then 0. 32. Right? Okay, so coming to the memory mapping, RAM is available with 8051, but the RAM is of 128 bytes, and memory mapping of RAM is what we are trying to see. So the lower 32 bytes are used as 32 bit, means 32 resistors. They are given as bank 0, bank 1, bank 2, bank 3. And register bank 1 is also mentioned as stack. And 20 to 2F, which has 16 bytes, they are bit addressable RAM. Means now 20 having 1 byte, and 1 byte has 8 bits. 1, 2, 3, 4, 5, 6, 7, and 8. You can make individual bit, you can store a bit at that particular memory. That is called bit addressable RAM. This is not available with 8086. So the next 16 bytes are bit addressable RAM, and 30 to 7F is scratchpad RAM. This is user area. Here you can use your program. 30 to 7F. These many bytes you can use for your writing your program of RAM. And coming to the stack, already we know what is stack. So this 10 to 1 register bank 1, which is of register bank 1, which is of 08 to 0F, can be used as stack. Stack, the difference between this memory and the other memory is stack is first in last out, but general memory is first in first out. FIFO, general memories are first in first out, but stack memory is last in first out kind of memory. Okay, and stack pointer is used to point out this particular memory, separate pointer. So the moment you power up, 8051 is power up, the stack pointer register is holding 07, means this 07, right, 07 is stack memory. Right, so addressing modes and all will be discussing in the next class. Okay, so up to now what we have seen is memory mapping of 8051. Right, memory mapping of 8051. So you have 4K ROM, 128 bytes RAM. In detail, we have seen 4K ROM means 0002, 0FFFF. Why 4 digits means, externally also you can connect ROM, so which is of 64K. 64K means 4 zeros to 4Fs, right? That's why the memory address are given, right? And this is of ROM, this is of RAM, and these are the registers, and each registers, here you have one more register of stack pointer, right? Stack pointer, program counter, data pointer, accumulator, base register, R0, R1, R2, R3, R4, R5, R6. This is of bank 0. Similarly, you have bank 1, bank 2, bank 3, bank 5. 32 general purpose registers. And we have seen the pins and we have seen the features. So now this is what the architecture. Now these are the registers in detail. All the registers. So once you know the registers, then programming will become very easy. So now this is what the ROM addresses, 3 zeros to 3Fs. And these are, the RAM. This is ROM memory mapping. This is RAM memory mapping. R0 to this is bank 0, bank 1, bank 2. This is bit addressable area, and this is general purpose area. Okay. And here you have registers accumulator, here you have register B. So this accumulator, straight away you can write a word A in the instruction, accumulator, or it has an address E0. You can give E0 address also in the instruction. This is not, you cannot do this in your microprocessor. Right? So then instruction pointer and timer control register, and this is serial control register, power control register. PSW is programmable status code. So which has carry flag, auxiliary carry flag, parity flag, zero flag, sign flag. These are the flags available with 8051. Okay, here you have program counter, data pointer, and ports also can be accessed with addresses 80, 90, port 2 A0 and port 3 A0, 80, A0, 90, right, and stack pointer, and then timer registers, timer mode register, timer control register. When I'll discuss timers, I'll discuss in detail about these registers. And when I discuss about the counter, then this I'll try to discuss about this. And interrupt enable register and IP instruction pointer. Okay, right? Yeah. So these are your serial data registers. So register organization of 8051 is what we have seen. Architecture is what we have seen. Pin diagram of what we have seen in this particular class, right? And in the next class, we will try to see the addressing modes, programming part. In programming part, we will try to see. Okay, we will try to see addressing modes and the way of writing program. By kill program also you can do these things. So 2 to 3 little sample programs is what I will try to discuss. So instructions and all we can cover, and then we can move on to port programming on timer control programming, which is very important. Same concept you can extend it to your Atmel microcontroller, which is Arduino board based. Okay, right? So with this we'll stop, and that's all for today, right? And then so just go through and then just brush up. If you have your processor knowledge, then you can go ahead with your microcontrollers. Is it all right? Okay, so I'll take off now, and then we'll meet again in the next class. So following is very important: microprocessor and controller one-to-one, one-to-one, one-to-one is okay. If you know those concepts, these concepts will become very easy. All right. If you have any questions, I can take up now. I think you can type the question in the window so that I can listen to you. If you have any questions, you can make this class interactive. You can. I think I cannot listen to you, but I think you can type your question. If you have any question in mind, you can type so that I can see, and then I'll answer so that you can listen. No questions means nothing understood. Okay, or otherwise everything understood. Okay, right. So if you have any questions, you can type. I can see on my screen. You can make it as this class as an interactive. Or otherwise, for the next class, you make your questions ready. Okay, right? Yeah, bye.